Hello everyone, we are going to continue a discussion on how to quantify matter, and for that purpose we are going to use moles. Now mole is an SI unit. It is a standard that is used by all the chemists in the world, and it measures the amount of a substance. A mole can be related to three things: number of particles, mass, and volume of a gas. On the next slide, we are going to start with the number of particles. We are going to relate moles to number of particles. And this is a relationship that we are going to use. 1 mole of any substance is equal to 6.02 times 10 to the power of 23 particles. Now, this particle can either be atoms, molecules, or formula units, depending upon the type of substance that is being discussed. Now let's start with a few numerical problems. This is where you need a calculator. Make sure it is available to you, and we can start working on how to solve a few questions. Question 1. How many moles are in 3.25 times 10 to the power of 20 atoms of lead? Okay, so this is a relationship that we are going to use. 1 mole is equal to 6.02 times 10 to the power of 23 atoms. The reason we changed the particles to atoms is because we are discussing about lead. Lead is an element, and for element, we measure the atoms as our particles. Okay, now we start with what is given to us in the question, which is 3.5 times 10 to the power of 20 atoms. Okay, we have to convert this into moles. That means we are going to use this relationship to have a conversion factor. Okay, we don't need atoms anymore as our unit, so atoms would be in the denominator. Moles is needed in the numerator, and we know that 1 mole is equal to 6.02 times 10 to the power of 23 atoms. Atoms and atoms get cancelled, and we are left with moles as our unit. Okay, in your calculator, this is what you have to do now. 3.25 times 10 to the power of 20 times 1 divided by 6.02 times 10 to the power of 23. Yes, you do need to use parentheses around the big scientific notation numbers, or very, very small numbers that are also given to us in scientific notation. Okay, and this comes out to be E5.40 times 10 to the power of -4 moles. This is a final answer. Let's look at question 2. How many molecules are there in 8.3 moles of sugar? Now, sugar has this formula, and this is a covalent compound. Okay, therefore, the relationship between moles and particles would be 1 mole is equal to 6.02 times 10 to the power of 23 molecules. We are going to start with what is given to us. This is what is given: 8.3 moles of sugar. And we are going to convert this into molecules. That means we need to use this relationship and come up with a conversion factor. We do not want moles as our unit, so moles would be in the denominator so that we can cancel it out. And we want molecules as in the numerator. Now, let's put the numbers next to them. 1 mole is equal to 6.02 times 10 to the power of 23 molecules. Moles and moles are cancelled, and we are left with molecules. Now in our calculator, this is what we have to do. 8.3 times 6.02 times 10 to the power of 23, and then we are dividing it with 1, which comes out to be 5.0 times 10 to the power of 24 molecules of sugar. Now let's look at this question. How many atoms are in 0.425 moles of sulfur? So this is what we are given. We're going to start with what is given to us and use this relationship. Okay, so 0.425 moles of sulfur. Now sulfur is an element, and therefore the representative particles for element would be atoms, and that's the reason we are converting this into atoms. Okay, now we need to cancel moles, so moles would be in the denominator, atoms would be in the numerator, and this is a relationship. 1 mole is equal to 6.02 times 10 to the power of 23 atoms. Moles and moles are cancelled, and in our calculator we need to do this. And it comes out to be 2.56 atoms of sulfur. Let's look at question 4. How many moles are in 5.42 times 10 to the power of 22 formula units of NaCl? In this question, we are given formula units. The reason is the substance that has been discussed is an ionic compound, and for ionic compound the representative particles are formula units, and that's why you're seeing formula units with NaCl. Okay, we're going to start with what is given to us, 5.42 times 10 to the power of 22 formula units, and we have to convert this into moles. So that's the relationship that we will be using. We want everything in moles, so moles would be in the numerator and formula units would be in the denominator. Now we are left with placing numbers next to them. 1 mole is equal to 6.02 times 10 to the power of 23. Okay, formula units get cancelled and we are left with moles. In the calculator, this is what we are going to do. Times 1, parentheses, divided by, parentheses open, 6.02 times 10 to the power of 23, close parentheses. And our final answer is 0.0900 moles of NaCl. Let's look at the last question. How many atoms of carbon are there in 5.3 moles of sugar? Sugar is a covalent compound, therefore we would use this relationship. 1 mole is equal to 6.02 times 10 to the power of 23 molecules. But the question is not asking us to calculate molecules. It is asking us to calculate how many carbon atoms are there in 8.3 moles of sugar. Now we need to use another relationship to get our answer. 1 molecule of C12H22O11 has 12 atoms of carbon. Okay, now we're going to start with what is given to us in the question. 8.3 moles of sugar, okay, which is C12H22O11. We're going to convert this into molecules first. Okay, so 1 mole is equal to 6.02 times 10 to the power of 23 molecules. Moles and moles get cancelled. Now we are left with molecules of sugar. Now we're going to use a second relationship. One molecule of sugar contains 12 atoms of carbon. Okay, molecule and molecule gets cancelled, and now in a calculator, this is what we'll be putting. 8.3 times 6.02 times 10 to the power of 23 times 12. Okay, and everything is divided by 1, which is equal to 6.0 times 10 to the power of 25 atoms of carbon.